Hi all, I hope you all are doing good. This is a short video lecture on the topic of random variables, which are also known as stochastic variables. So let us try to understand the meaning of random variables through an example. So let us say we have this football match going on, and this player has been awarded 2 penalty kicks. So the possible outcomes related to this event of player having attempting 2 penalty kicks could be uh, either the player scores goals on both the occasions of 2 penalty kicks, or the player is able to score the goal on the first occasion but misses in the second attempt, or the player misses in the first attempt but is able to score on the second attempt, or he misses on both the attempts. So now what does this random variable mean? So basically random variable is a function which is considered from sample space S to set of real numbers R. So what do we mean by this is that this function, that is capital X, which is known as random variable, it will pick the possible listed outcomes from the sample space S, and it will associate a real number to all those listed possible outcomes. So in this example, in this case, we are referring about a function which is random variable X, which counts the number of goals scored by this player with the 2 penalty kicks he attempts. So that means my random variable X, based on the sampled outcomes, can have these possible values, that is 0, that is no goals are scored in both the penalty kicks, or 1 goal has been scored, or 2 goals are scored from both the penalty kicks. So you can see that this random variable X has actually considered this outcome of 2 goals scored on those 2 attempts and associated a real number 2 with it. Similarly, this outcome of no goals being scored has been associated with a real number 0, right? And likewise, these two outcomes of scoring a goal either in the first attempt or in the second attempt has been associated with a real number, that is 1, right? So this is what essentially we mean. A random variable will associate a real number to the all listed possible outcomes in your sample space. So let us see another example. Let us say we have a, a roll of dice and a pair of dice, and we have this sample space S for the same, that is 1 1 1 2 up to 1 6, and it goes like this: 6 1 6 2 up to 6 6, right? Now we say that this random variable X is a function which is defined from the sample space S over set of real numbers S. So now I will define my function for this random variable X, like let us say uh, X of I comma j, that is the sum of, let me just write it in this way, X of S is equals to sum of two numbers on appearing on the dice, pair of dice, right? So that means if I talk about if we just refer our sample space, then we can see that if I talk about, let us say 1 comma 1, right, then that will be what, 1 plus 1 is equals to 2. If I talk about 1 comma 2, then it will be what, 1 plus 2 equals to 3. Likewise, if I talk about X of 1 comma 3, that will be what, 1 plus 3 equals to 4, and the same will go on till we have this element 6 comma 6. So x of 6 comma 6 is what? 12. So this means that the possible values that this random variable x can associate, possible real number values that this random variable x can associate with all the listed outcomes in the sample space are what? It starts from 2, 3, 4 up to what? Up to 12. Right, so you can see again that this random variable x, which was defined on sample space R as over set of real numbers R, as the sum of two numbers appearing on the dice, has the values starting from 2, 3, 4 up to 12. Okay, so it has associated a real number to all the listed outcomes in the sample space. So I hope this is again absolutely clear with you all. So yeah, so now let us understand that what different types of random variables we can have. So one is discrete random variable, and another one is a continuous random variable. All right, now let us try to understand with the help of an example. See, when we talk about discrete random variable, what we try to say is that this random variable x, if it is discrete in nature, then that means it can have a countable number of values. It can have only specific or countable number of values. So for an example, if I talk about a person visiting Eiffel Tower, then the number of steps which is walked by the person uh, visiting the Eiffel Tower will be a discrete random variable, right? Because we know that you can have a counting number for the number of steps. You can have 22,000, 25,000, you cannot have 25,000.2, right? So that's what we mean by a discrete random variable. But if I say that let us say the time the time a person stays at the top of the Eiffel Tower when he reaches there, right? So the time a tourist, a visitor stays at the top of the tower, so that is your continuous random variable. I hope this is clear with all, that what do we mean by a discrete and continuous random variable. Okay, yeah, so there are actually number of examples for this discrete random variable and for this continuous random variable. So let us say, if I talk about the examples of discrete random variable, so it could be the number of sales. All right, then it could be the number of phone calls, right? Then it could be shares of stocks, right? Then people standing in a line. All right, then what else? Mistakes in a slide, or mistakes per page, right, in exam. So yeah, so these are the examples of discrete random variable. All right, likewise, if I talk about continuous random variable, then in case of continuous random variable, let us say we can take the example of length All right, then we can have the example of depth. All right, then we can consider volume again. All right, time, right, then weight. All right, so there are a number of examples for the same, that is continuous random variable. So let us quickly do an exercise in which you have to label the listed random variables and classify them in terms of either discrete or a continuous random variable. I hope you people will be able to do it. And so I would like to stop my I would like to keep this video lecture a short one, so I will stop over here, and in the next video lecture we will see that how we can use this concept of random variable to create a probability distribution function. All right, so yeah, wish you a good time learning this concept. Bye bye, take care.